Welcome to this Coreform Cubit tutorial. My name is Randy Morris. In this tutorial, we are going to take a close look at Cubit's command parser, with a particular emphasis on what we call extended parsing. Cubit power users are masters at using extended parsing. And since I want you to become a Cubit power user, understanding these concepts will propel you towards that end. Let's get started. First, let's open up the help. We're going to go to controlling the application. We're going to scroll down to entity selection and filtering. We're going to look at command line entity specification. Your homework today is to go back to this section when we're finished and dive in a little bit deeper, play with the examples, and try to understand what we're trying to do in terms of specifying entities at the command line. You can see we have several categories of command line specifications, including general ranges, combined geometry mesh and genesis entities, mesh topological traversal, etc. For today, we're going to play with just a couple of little examples here with a very simple model just to show you how this works. The in identifier under topological traversal is key. It's how we navigate through the topology of a model to understand what's really there, who owns what. So let's take just a simple example. I'm going to grab this string right here, this draw hex in face and surface 2, which seems to be very strange. I'm just going to copy that. I'm going to collapse my help, and we're going to make a brick and mesh it. Let's go ahead and paste that command into the command line and see what happens. The command says this: look at surface 2, find all of the faces, in this case the quads, and then draw the hexes associated with those quads or faces in surface 2. If I were to click this button up here, which is display, it returns the model to its normal rendering. Let's draw all the nodes in the faces in surface 2. So we're going to look at surface 2, find all of the faces associated with surface 2, and then we're going to draw all the nodes in those faces. And it's going to look something like this. Again, nothing fancy, but it gives you the idea of how we can traverse topology in Cubit using the in operator. Now let's spend some time looking at the extended parsing. We'll go back to the documentation, click on this link, Extended Command Line Entity Specification, and this takes us to what we refer to as extended parsing. The documentation shows us a list of keywords, shown here on this page, as well as a list of functions available for extended parsing. Today we're going to look at just a couple of these things as examples, but again, you've got homework. After this video, dig into the documentation and play with some of these functions and keywords and become a Cubit power user. I created this cute little plate with a few plugs in it. What's interesting about it is each of these plugs is a different radius, has a different surface area, has a different volume, and we're going to use that information as we experiment with extended parsing. I can enable the volume selection and select some of these volumes. I'm curious to know what their volumetric value is. In this case, it's 0.4. In this case, with this large one, it is 6.5, and this medium one is 1.6. So my intention is to use these plugs in a Boolean operation to create some holes in this plate. We're going to subtract volumes all with volume less than 0.5 from volume 1. It's a lot of volumes. What we're saying here is this: we're going to subtract any volume that has a volumetric value less than 0.5. This with volume is the extended parsing keyword, with volume less than 0.5 from volume 1. And you can see that we remove those plugs and effectively put holes in this plate. Grabbing another command, this one will actually generate a warning. And this one I said subtract volume all with volume greater than 1.7 from volume 1. Well, as it turns out, volume 1 itself has a volume greater than 1.7. So ASUS, our solid modeling kernel, said we can't subtract that body from itself. So how will I do this then? How will I get the rest of those volumes subtracted out of the main volume? The corrected syntax will look something like this. Subtract volume all with volume greater than 1.7 except volume 1 from volume 1. So to overcome the warning, we simply added the except volume 1 from the syntax and got the result that we wanted. Let's go ahead and get the rest of these. And there we go. We subtracted all the volumes with a volume greater than 1.5 except volume 1 from volume 1. Now let's use this same type of syntax to start removing those holes or filling those holes. And the way that we do that is with a tweak surface command. So let's go ahead and work on this top left hole right here. And I want to go into surface select mode. I want to select that surface internal. And you can see that the selection grabbed that top surface. I'm going to hit the tab key. And that will take me to the next one. That's surface 45. Now that I know that, I can use a tweak command on surface 45 to remove that hole. So the command to do that was there. Tweak surface 45, remove, extend. Now let's undo that and try this a couple of other different ways. So I'm going to go up here to undo, click undo. This time I want to select that surface and I want to select other surfaces of the same size so I can do the same operation. In other words, I want to remove all 4 of those holes on the corner. So let's see how that works. Again, I'm going to select that surface, hit the tab key, right click the context menu and select similar surfaces. And there you can see I've got all 4 of those surfaces selected. Now I could go into this command using the up arrow, add these surfaces right here that I've selected into my list, hit return, and all 4 of them are gone. But I want to show you one more way to do this also. So let's undo, put those surfaces back. Let's use the command panel this time and see how this might work in the command panel. So I'm going to go to Geometry, Surface, Modify, Tweak, Remove. Got all of these different tweak options in here. So the surfaces I want to remove are the same ones we had in that last example. So I'm going to go ahead and activate the pick widget by clicking into the pick widget. Select that surface, tab key, there's 45. I'm going to select similar surfaces and you can see they all get populated in the command panel. Extend is already selected. If I hit preview, then I can see these holes will still be there, but these holes will be gone. So if I hit apply, there we go. Now let's undo that and try this one more time. This time I want to keep all of the corner holes and remove everything else. So we can do this from the command panel and still use extended parsing. First of all, let's look at those surfaces, measure their areas so I can understand how to use extended parsing in this case. So I will select that same surface, tab key. Over here in the property page you can see I've got surface 45 selected. If I go into surface area in calc, I can see that's 1.5. If I select this surface here, tab key, surface area is 3.1. Select this large surface, surface area happens to be 6.2. So now I know this. I can use extended parsing to remove all of those surfaces. In other words, fill all of those holes except for those 4 small holes on the corner. Let's do that in the command panel using extended parsing. We should know this. The command panels are nothing more than little widgets that build Cubit commands. So there's no difference from the commands that are generated from a command panel compared to those that we type by hand at the command line, which means all of these edit fields can contain anything that's valid in the commands. I can go into my command panel and, using extended parsing syntax, add that to the command panel. Again, that's just going to generate a normal Cubit command. So if I hit apply right now, I can see that all of the holes were filled except for the 4 small ones at the corner. Let's undo that and look at something else that's interesting. I'm going to put that syntax back in here. I'm going to right click and say draw. Did you see what happened there? I've got this syntax in the pick widget, so any pick widget that has data in it, I can right click and draw normals, locate, highlight, anything I want to do. In this particular case, I said draw, and that told me which holes were going to be filled based on the extended parsing syntax in the pick widget. Let's take a quick look at the keyword with, and then the functions numParents and isMerged. For an example, this command, draw curve with numParents equals 1. Draw curve with numParents equals 2. Draw curve with numParents greater than 2. We'll go ahead and reset our display. And this time, let's merge all the bodies with a y-coordinate greater than -0.01 and issue a similar command for these. This time we're going to highlight. We highlighted the curves that have 1 parent. Let's highlight the curves that have 2 parents. And then let's highlight the curves that have more than 2 parents. Let's go ahead and merge everything. We have a tool on the GUI that helps us see the same information in just a little bit different way. It's up here at the top. If I click that, I can see curves colored. The orange curves have only 1 parent, the blue curves have 2 parents, and the white curves have more than 2 parents. I'm going to issue this command, highlight curve with isMerged. So the isMerged function shows us the merged entities, but the numParents function gives us a classification of the type of merge for those entities. I hope you found this useful. This is Randy Morris. Until next time.